Welcome to the AI Ethical Hacker Certification Overview. This certification validates individuals' ability to use AI methodologies for cybersecurity, enhancing organizational resilience against cyber risks and promoting ethical integration. It provides insights into AI transformative impact on digital offense and defense strategies, catering to tech enthusiasts seeking to master AI fusion with ethical hacking practices in the rapidly evolving digital landscape. Module 1. Module Foundation of Ethical Hacking. This module outlines the ethical hacking process, defines its legal boundaries, and examines the structured methodology used by ethical hackers. It covers reconnaissance, scanning, and controlled exploitation to identify and mitigate vulnerabilities. The module also covers regulations and best practices for ethical hacking. It covers different hacker types, information gathering techniques, advanced tactics like footprinting, reconnaissance, and network scanning, and enumeration techniques to extract critical information from compromised systems and understand their security weaknesses. Module 2 explores the use of AI in ethical hacking, covering fundamentals, AI technologies, machine learning, natural language processing, deep learning, adversarial machine learning, AI-driven threat intelligence platforms, cybersecurity automation with AI. Module 3 explores the use of AI tools and technologies in ethical hacking, including threat detection tools, machine learning frameworks, penetration testing tools, anomaly detection tools, network security solutions, automated vulnerability scanners, AI in web applications, malware detection and analysis, cognitive security tools. Module 4 explores AI-driven reconnaissance techniques, including ethical hacking, traditional versus AI-driven reconnaissance, automated OS, fingerprinting, AI-enhanced port scanning, network mapping, social engineering reconnaissance, OSINT, and DNS enumeration, and target profiling. Module 5 discusses the use of AI in vulnerability assessment and penetration testing, including automated scanning, enhanced tools, machine learning for exploitation, DAST, fuzz testing, adversarial machine learning, automated report generation, AI-based threat modeling, and challenges and ethical considerations in AI-driven penetration testing. Module 6 covers machine learning for threat analysis, including supervised learning for threat detection, unsupervised learning for anomaly detection, reinforcement learning for adaptive security measures, natural language processing for threat intelligence, behavioral analysis, ensemble learning for improved threat prediction, feature engineering, machine learning in endpoint security, and explainable AI in threat analysis. Module 7 covers behavioral analysis and anomaly detection for system hacking, including biometrics for user authentication, machine learning models for user behavior analysis, network traffic and endpoint behavioral monitoring, time series analysis for anomaly detection, heuristic approaches, AI-driven threat hunting, user and entity behavior analytics and challenges and considerations in behavioral analysis. Module 8. AI-enabled incident response systems include automated threat tagging, machine learning for threat classification, real-time threat intelligence integration, predictive analytics, AI-driven forensics, automated containment and eradication strategies, behavioral analysis, continuous improvement through machine learning feedback, and human-AI collaboration in incident handling. Module 9 highlights the use of AI-driven user authentication techniques, behavioral biometrics for access control, anomaly detection, dynamic access policies, AI-enhanced privileged access management, continuous authentication using machine learning, automated user provisioning and deprovisioning, risk-based authentication, and AI in identity governance and administration. AI enhances user authentication by analyzing behavior, detecting anomalies, and implementing dynamic access policies. It automates user lifecycle management, reducing risks and allowing IT resources for strategic initiatives. Module 10 focuses on securing AI systems, including preventing adversarial attacks, implementing secure model training practices, ensuring data privacy, deploying AI applications securely, ensuring model explainability and interpretation, ensuring robustness and resilience, transferring and sharing AI models securely, and continuously monitoring and detecting threats. Module 11 covers the ethics in AI and cybersecurity, which includes ethical decision-making, bias, transparency, privacy concerns, accountability, responsibility, threat intelligence sharing, human rights, regulatory compliance, ethical hacking, and responsible disclosure in AI-driven cybersecurity. Module 12 includes a capstone project that focuses on enhancing threat detection and response using AI, addressing ethical hacking with AI integration, incorporating AI in identity and access management, and ensuring the secure deployment of AI systems. Visit our website and enroll in the AI Ethical Hacker certification today.